Hi, I'm Jhon Ormita.
I'm Gomelan.
And I'm Princess Ramos.
And I am Tyron Bechayda.
And we are the OwlQuery.
And today, we will be presenting to you our capstone project titled RFID and Barcode-Based Library Management System for Bigutan Parochial School. Bigutan Parochial School is now upgrading from a manual logbook system to an RFID and barcode-based system. This upgrade automates tracking of library users and books, making the process faster, more accurate, and more efficient for both students and staff. Our client is Dr. Salvacion Dinson, the school librarian of Bigutan Parochial School. The school is located at Manuel L. Quezon Street, Lower Bigutan, Taguig City. It promotes both academic excellence and spiritual development to provide students with a well-rounded education. It uses RFID technology for attendance logging and barcode scanning for book transactions. The system also includes online reservations, email notifications, and report generations. Currently, the school library still uses manual logbooks and handwritten records. As a result, the librarian faces difficulties in maintaining organized records and monitoring which books are borrowed or returned on time. This manual process also consumes valuable time that could have been used for the other important library tasks. Because of these challenges, students are less encouraged to use the library, and the overall efficiency of the library operations is greatly affected. Our goal is to design and implement an RFID and barcode-based library management system that will streamline and automate library operations for Bigutan Parochial School. Let's walk you through our main objectives and what we want this project to accomplish. First, we aim to automate and streamline library operations, making every process faster and more efficient. Second, to improve accessibility and enhance user experience through the integration of RFID and barcode technologies, ensuring a smooth and convenient system for both students and staff. Third, to simplify the borrowing and returning process so users can transact with ease and less waiting time. Fourth, to enable accurate attendance tracking using RFID technology, removing the need for manual logbooks. And lastly, to provide efficient management of library resources, allowing librarians to easily monitor books, records, and user activities. Through these objectives, our system ensures that the Bigutan Parochial School Library becomes smarter, faster, and more user-friendly than ever before.
For our literature review, we explored several existing library systems and understand their strengths and areas for improvement. Let's begin with the PUP Taguig Library Information System. The system enables fast book searches, Excel report generation, and analytics with improved book request process, but lacks data backups, bulk import, overdue reminder, advanced time logging, and Google search integration. Moving on, the Smart Library RFID-based system in the LPU Laguna Library. It offers advanced features like real-time inventory updates via RFID and barcodes, along with a dynamic dashboard for usage statistics. However, it lacks mobile accessibility, reminder notifications, and integration with academic systems such as student portals and payment gateways. Lastly, the Digital Library Management System at the University of Mumbai. It manages book circulation, report generation, and an online public access catalog, but lacks RFID or barcode integration to automate borrowing and returning of books. In synthesis, early studies revealed that library systems mainly focuses on automating attendance, inventory, and circulation. Traditional methods are slow and error-prone, while RFID and barcode technologies enhance accuracy and efficiency, enabling real-time tracking, easier reporting, and improved resource management.
Chapter 3 presents the methodology that used for system development and evaluating our proposed system. It discusses the processes, methods, and tools that guide the system from its planning stage to implementation and testing. Through this methodology, we ensure that the system is built systematically, evaluated objectively, and aligned with the needs and expectations of our client and users. For our system development, we use the Agile development methodology. Agile focuses on flexibility, collaboration, and continuous improvement, allowing us to gather feedback from our client and make adjustments throughout the development process. This methodology follows 6 main phases. First are the requirements. We first gather the needs and expectations of our client to fully understand what features and functions the system must include. Next is the design. We create mockups and system architecture to visualize how the system would look like and operate. Next is development. We proceed to build the actual system modules based on the approved design. Next is testing. Once the feature was completed, we immediately tested it to ensure the functionality, security, and performance. Next is the deployment. The system was then deployed in a live testing environment for client evaluation. Lastly, the review. We gathered feedback from our client, identified necessary improvements, and repeated the process as needed. This cycle continues until the client is fully satisfied with the outcome, making Agile the most suitable approach for a collaborative and user-centered development. To support the development process, we also conducted research to assess user satisfaction and system performance. We use a quantitative and descriptive research design. This allows us to gather measurable data and describe the system's effectiveness in a clear and structured way. The study used stratified random sampling to ensure fair representation of all subgroups within the population of library users at Bigutan Parochial School. We conducted the user acceptance testing or UAT through Google Forms and a survey questionnaire to gather feedback on a system's performance and usability. A sample size of 241 participants consisting of 227 students, 8 faculty members, and 6 staff members was determined using Slovin's formula with a 5% margin of error and a 95% confidence level. This method ensured accurate and unbiased representation of the population. This slide illustrates the architecture of our library management system. On the left, we have our users. Library users, like students and staff, tap their IDs on an RFID scanner for quick identification. Visitors register directly on the main terminal, while the admin uses a barcode scanner for managing books and has direct system access. All inputs are processed by the central BPS library management system. The system is powered by 4 core modules. First is the attendance module, used to log user and visitor entry. Next is e-library module for accessing digital resources. Next is book circulation module to manage borrowing and returning of books. Lastly is the admin module for overall system management and reports. All data from these modules is stored in a single unified BPS LMS database. In essence, this architecture integrates various users and functions into one efficient, organized, scalable system. For the system's development, we utilize several modern tools and technologies that fit our requirements. These include Laravel for backend web development, PHP as the main programming language, JavaScript for interactive and dynamic functions, Bootstrap and Tailwind CSS for a clean and responsive interface, MySQL for database management, and Notion for project documentation and task organization. All these tools work together to build a system that is not only functional but also user-friendly and efficient. Overall, Chapter 3 highlights how our methodology, research, and chosen technologies work hand in hand to develop a system that truly meets the needs of our client and users. Next, let's cover the system requirements. We've divided this into 2 categories, the hardware and the software. For the hardware, the minimum for a client or admin terminal is an Intel Core i5 processor, 8GB of RAM, and 256GB of storage. A stable internet connection of at least 10 MB per second is essential. For the peripherals, we need a 13.56 MHz RFID scanner and a 2D barcode scanner. For software, the system runs on Windows 10 or Mac OS and is accessed through any standard web browser. On the development end, the system is built with Laravel, PHP, Bootstrap, Tailwind CSS, and Ajax. For deployment, Hostinger is used for web hosting. These are the minimum specifications to ensure the systems run smoothly.
We conducted the initial system testing at the BPS library, where library users were able to register, tap their RFID for attendance, borrow and return books, and explore the other features of the library management system. On August 1, we conducted the initial testing for library users at the BPS library. During these sessions, users were able to register their accounts and test the RFID tapping for attendance. We also conducted user acceptance testing, or UAT, through Google Forms to gather initial feedback for participants regarding system usability and functionality. On August 15, our team prepared the production environment by importing student data, checking all computers to be used, and setting up the system. After the setup, we proceeded with the initial testing of the RFID attendance feature to ensure that the system correctly detects and records RFID taps in real time. On August 22, we guided the librarian in using the system and conducted testing for book borrowing and returning. This testing confirmed that the circulation module functions accurately, successfully recording borrow and return transactions while updating book status in the database. On September 12, we started the encoding and barcoding of books for circulation. We also conducted a user acceptance test with library users through a survey questionnaire to collect their feedback regarding their experience in the new library management system. On September 17, we assisted the client in encoding and barcoding the remaining books. Some library visitors arrived and were able to test the visitor form. The UAT survey was still ongoing to gather responses on their experience using this new system. On September 19, some books were officially made ready for circulation. Some students began borrowing books through the system. We also conducted another round of user acceptance testing through survey questionnaire to assess the overall usability of the library process. On September 29, we imported the faculty and staff data into the system. We also assisted and guided faculty members in using the system and helping students in returning their borrowed books. This ensured that both faculty and student transactions were recorded properly in the database. On October 1, we continued by assisting and guiding faculty and staff members in using the system. During this session, we also distributed a survey questionnaire to collect their valuable feedback regarding system functionality. And lastly, on October 8, we uploaded student photos to the system as a part of profile management. On the same day, the MOA signing ceremonial was held, where research advisor Sir Francis Franco personally tested the visitor form feature of the system. This serves as a demonstration of the visitor logging process for future implementation. Overall results of the user system evaluation of the BPS library management system gathered from 241 library users such as students, faculty, and staff. This shows strong agreement across all indicators. The system received positive ratings in every category, with functional sustainability at 4.54, performance efficiency at 4.37, compatibility was rated at 4.37, usability with a score of 4.45, reliability was rated at 4.37, security at 4.42, maintainability was rated 4.39, portability at 4.32, and overall assessment received the highest score at 4.61. The results show that the respondents consistently viewed the BPS library management system as dependable, efficient, and excellent quality, with an overall mean rating of 4.43, which is interpreted as strongly agree. In conclusion, the BPS library management system has proven to be an effective system that supports better library management and offers strong foundation for future development and integration. Based on the evaluation results, the BPS library management system achieved an overall mean rating of 4.43, which is interpreted as strongly agree. This means that the system successfully meets user needs and performs well under the ISO or IEC 25010 quality standards. Overall, the system improves efficiency, accuracy, and accessibility in managing library operations, book transactions, and attendance tracking. It provides a reliable and high-quality solution compared to the traditional manual process.
Based on the client's evaluation and feedback, several recommendations were suggested to further enhance the system. The client recommended integrating the library system with the cashier system through an API to automatically record and process student penalties for overdue or lost books, reducing manual coordination and ensuring accurate fines. They also suggested developing a printing service module to track printing activities for audit and transparency report. Lastly, they proposed implementing MARC or machine-readable cataloging to standardize bibliographic records, enhance catalog organization, and ensure compatibility with other library systems.
Now, here's our implementation plan covering from orientation up to maintenance. First is the orientation. We conducted a short session with the librarian and ICT staff to introduce the system's features and objectives. This lasted for one day, held on August 1, 2025. Next is the system installation and configuration. We installed the system on school computers, set up RFID readers, barcode scanners, and connected the database. This also took one day on August 15, 2025. The next is the training and user familiarization. We trained the librarian and staff to ensure they can use the system properly. This lasted for 2 weeks from August 22 to September 5, 2025. Next is the pilot testing. We tested key functions such as RFID attendance logging, book scanning, and report generations. This phase lasted for 6 weeks from September 12 to October 24, 2025. Next is the monitoring and feedback. During the same period, we collected feedback from users and librarians to evaluate performance and make improvements. This also ran for 6 weeks from September 12 to October 24, 2025. Next is the full implementation. The official deployment of the system for daily library operations happened on November 3, 2025, lasting one day. Lastly is the maintenance and updates. This is a continuous phase for providing technical support, bug fixes, and performance monitoring after deployment.
Through this project, we aim to help the Bicutan Parochial School to modernize its library operations and improve efficiency.
With this system, library transactions become faster, more organized, and more accessible for library users.
And once again, we are the OwlQuery. And this concludes our presentation on RFID and barcode-based library management system for Bicutan Parochial School.
Thank you for watching.